Right, so today in the OMG It's Core Chemistry, we're going to be looking at catalysts. So first little thing, a definition of what catalysts are. So catalysts increase the rate of reaction but remain unchanged. So them themselves remain unchanged. So they can be reused, that's an advantage of them. They can be reused, but are specific to each reaction. So if I wanted to make ammonia, which is used in nitrogen fertilizers, then there's one specific catalyst I can use. I can't use loads of different catalysts, okay? Catalysts lower activation energy. Remember, activation energy is the minimum amount of energy required for a reaction to take place. Okay, so the minimum amount of energy required for a reaction to take place. So if that energy is lower, more particles are going to have enough energy to react. That's what it says there, more particles have enough energy to react. They are quite expensive to make, but they can be used numerous times. Okay, and this is what it looks like, okay? Catalysts, they lower the amount of energy required for the particles to react. So before, particles had to get to this energy, say it's 50 joules, so just making numbers up. So it's 50 joules by here. So not all the particles are going to have that energy. But if you make it 25 joules, more particles are going to have the energy required to react, so you're going to have more successful collisions. So same kind of thing. I know it's quite... it's a short topic, but let's have a go at looking at having a go at the questions. So what is a catalyst? They lower activation energy without being used up. What is activation energy? Minimum amount of energy required for a reaction to take place. An advantage can be reused. Disadvantages are expensive and they're specific, so they only work with one type of reaction. What is an energy profile? An energy profile is just showing the energy required to break the bonds in the reactants. So the energy required to break bonds in the reactants, form new bonds in the products, and how much activation energy is required. So how much, I'll just write that, activation energy is required. So an energy profile shows you how much energy is going to be required to break the reactants, form new products, and how much activation energy, so how much energy the particle is going to need to have a successful collision. How is a catalyst on an energy profile different? It's lower. It lowers activation energy. So say this was my energy profile. That's the energy required, so the energy goes up the side. That's the energy there required to break the bonds in the reactants. That's the energy there required to form new bonds in the products. And then that's the activation energy, so the minimum amount of energy required for a reaction to take place. If I had a catalyst, it would be lower, so I'd need less energy for the reaction to take place.